Hi class, and welcome to demonstration video for brief exercises 6-2, 6-6, and exercises 6-1 and 6-2. Now all of these exercises are going to pertain to future values, and I will show you which tables to use. Your homework problems will be very similar, so make sure that you follow along and have a good understanding before you go ahead and attempt the assigned graded homework. So for our first one, we're going to do brief exercise 6-2, and this will be on page 347 of your book. Okay. Now I'm going to, first of all, I'll read you the problem, and once that's done, then we'll get into, I'll show you how to calculate it. Okay. So brief exercise 6-2, BE 6-2. Bill O'Brien would like to take his wife, Mary, on a trip 3 years from now to Europe to celebrate their 40th anniversary. He has just received a $20,000 inheritance from an uncle and intends to invest it for the trip. Bill estimates the trip will cost $23,500, and he believes he can earn 5% interest compounded annually on his investment. Will he be able to pay for the trip with the accumulated investment amount? Okay, so basically, he's at $20,000 and he needs $23,500 total for this trip. And he's taking the trip in 3 years from now. So because we are investing one single amount, we're going to be using table 1, which is on page P-1 at the end of your book. And this table it's used to calculate the future value of any single amount. And we are just going to calculate the future value for that $20,000. And we're going to see if he's going to be able to invest that $20,000 to get to his goal amount of $23,500. All right. So the present value right now, the present value is $20,000. Okay. Let me just enlarge this so that you can see it a little better, hopefully. Let me just zoom it to 130. Okay, hopefully that's better. All right, so present value is $20,000 right now. We're looking at future value. Okay, right now he's got $20,000. In the future, how much is he going to get if he invested at 5% compounded annually? Okay. So the way we set this up is the future value of $1. Okay. Our N, or our number of periods, is 3 years. Okay, because he's going on the trip 3 years from now. His interest, or I, is 5%. Okay. So basically what you're going to be doing is you're going to take that 20,000, you're going to multiply it by the factor, and the way you can tell which factor to use is if you look on page P-1, he's investing it at 3%, so you would go up. The top of the table's got percentages: 1, 1.5, 2, 2.5, and 3. And you go all the way down to 3 years, and he's investing this at 5%. So there's 5% at the top. The number, or N, is on the side. Going down, it's at 3 years. You go all the way to the 5%. And your factor is going to be 1.15763. Okay, so that is what you multiply it by. So your answer will be times 1.15763, and that is the amount in which he will have 3 years from now. Is that enough to take his wife on the trip? Because for that amount, it's $23,152.60, and he actually needs $23,500. So he'll be a little bit short. I'm just gonna subtract the $23,500. He'll be about $347.40 short. Usually, we'll round this to the nearest dollar, but we're doing this. You get the concept of it. So you actually know what we're talking about, hopefully. So that's basically how you calculate that. And the answer is no, he won't be able to pay for the trip because he'll be $347.40 short. Okay, so that's how you do that problem. Okay, the next one is brief exercise 6-6. This is on page 348. Okay, so this brief exercise pertains to Leslie McCormick, and in the spring quarter of her she's in the spring quarter of her freshman year in college. She and her friends already are planning a trip to Europe after graduation in a little over 3 years. Leslie would like to contribute to a savings account over the next 3 years in order to accumulate enough money to take the trip. Assuming an interest rate of 4% compounded quarterly, how much will she accumulate in 3 years by depositing $500 at the end of each of the next 12 quarters, beginning 3 months from now? So keep in mind she is depositing money into this savings, which is at 4% compounded quarterly for the next 3 years. And there's 4 quarters in a year, so that's why it's saying the next 12 quarters. Okay, so she's depositing money 4 times a year. And because she's depositing more than 4 times, well, she's depositing more than once per year, we're going to use table P-, it's on page P-3, table 3, and this table is labeled as future value of an ordinary annuity of $1. This table is used to calculate the future value of any series of equal payments made at the end of each compounding period. Okay, so basically what we're going to be doing here is the future value of an annuity is $500. Okay, N is 12 or 12 quarters. Our interest hold on here. Okay, so as for our interest, it will equal 1%. The interest is 1% because the total interest of 4%, which is stated in the problem, is compounded quarterly, which means, because if you look on page 323, when interest is compounded quarterly and the annual interest rate is 4%, you would divide that 4% into 4, which is 1%. Okay, so for example, if you look at page 323, if the interest rate for the compounding period is 12% and it's compounded semi-annually, meaning twice a year, you would divide that 12% to 2, which would equal 6% at a 6% rate. If that 12% was compounded quarterly, then you would divide that 12% by 4, because there's 4 quarters in a year. So your percentage will actually be 3%. So in this case, we had 4% divided by 4/4 equals 1%. Okay, so that's our interest there. All right, so if we look at our table on page P-3, 1% for 12 periods is at 12.6825. That's our factor. Okay. That is 1% for 12 periods. Oops. Okay. Let me just scroll down a bit so we see that. Okay, there we go. All right, so basically I'm going to take my 500 times 12.6825, and my future value of an annuity amount will be $6,341. Okay, so that's how much. Now, what is the name again? Leslie. That's how much Leslie will have at the end of when she graduates college, and she'll have that much to go to Europe. So that is brief exercise 6-6. I'm just highlight this and highlight this. And what I'm going to do with these is I'm going to save them, and then I'm going to also post them in the learning plan so that you have access to them to follow along later on when you are maybe doing your homework or doing your practice problems, so that you don't have to refer back to the video, but you can refer back to these notes. Okay. Let's not save that yet. Okay, good. So let's see. I'm gonna insert a sheet. Okay. I'm kind of running. I don't want to keep going down, so I'm going to insert a second sheet. And here I'm going to do our exercises. And exercise 6-1 and 6-2. Okay. All right, these exercises are on page 348 and 349. And let's start with exercise 6-1 first. Okay, so in exercise 6-1, they gave us invested amounts. They gave us interest rates. And they gave us the number of periods. Okay, so in each one, they gave us 3 different, oh boy, okay. There we go. Let me just get this straight. Okay, so our invested amount for the first one is $15,000. Second is $20,000. Third is $30,000. And the fifth one is $50,000. Okay. Our interest rate for the first one is at 6%, 8, 12, and 4. Oops, well, that's it. Come on. 6, 8, 12, and 4. There. Excel is funny that way. And the number of periods is 12, 10, 20, and 4 and 12. Okay, so we have this table here in exercise 6-1, and it's asking us to calculate the future value for each of these single amounts. So, because it's asking for the future value of a single amount, we will be using table 1 on page P-1, and it says right there, it is used to calculate the future value of any single amount. Right at the top of page P-1, use table 1, future value of a single amount. Okay, this will be on page P-1. All right. So for the first one, let me skip a line. Well, no, we don't have to. All right. So our first amount is 15,000. Okay. And if you look at the table, let me just delete these here. Okay. Future value of 15,000. Our number of periods is 12. And our interest is 6%. Okay. So if you look on that table, 12 periods at 6%, our factor is going to be 2.01220. Okay, that's the factor that we're going to multiply our 15,000 by. So basically what we'll do is take 15,000, multiply by 2.01220, and we'll get, and I didn't put my decimal in there. There we go, that looks better. That is our amount then, 30,183. Okay, so that's the amount for 1. For 2, future value of 20,000. That's what we're looking for. Okay, our number of periods is 10 periods. Our interest is 8%. And our factor then will be, if you look at that same table on page P-1, 10 periods at 8% is 2.15892. Okay, so basically what I'll be doing is taking 20,000 times 2.15892, my future value of the 20,000 at 8% for 10 periods is going to be $43,178.48 10 years from now. Okay. 3. We're looking for the future value in the amount of 30,000. We're going to invest that 30,000 over 20 periods at an interest rate of 12%. If you look at the table again, 20 periods at 12% is going to be 9.64629. That's the factor we're going to multiply our 30,000 by. So basically, this is going to be my formula, 30,000 times 9.64629. And if I take that, my future value invested, my future value of 30,000 invested at 20 years at 12%, I will have $289,388.70. Okay, let me just highlight these so that's a little easier for you to see. There you go. All right. And for 4, We're looking for future value in the amount of 50,000. Okay. The number of periods is 12 periods at an interest rate of 4%. Our factor then will be, if you look at the table once again, 4% for 12 periods. Our factor will be 1.60103. So my formula is going to be 50,000 times 1.60103. And if I calculate that, my future value invested at, well, my present value of 50,000 invested at 12 periods at 4%, I will have $80,051.51 after 12 periods if I invest $50,000 and it was compounding 4% interest. Okay, so this is basically what we have for exercise 6-1. This was in the problem of the book, and what it basically asked was, hey, you have these amounts here. Right now you've got 15,000. You're going to invest it for 12 periods or 12 years at 6%. How much am I going to get at the end of those 12 periods? You're going to have $30,183. Second scenario, you've got 20,000 right now. You're going to invest it for 10 periods at 8%. You're going to have $43,178.40 at the end of those 10 periods, and so on. Okay? So that's what that is for exercise 6-1. And let's continue to 6-2. I'm going to do it over here so it looks a little more neat. Okay. All right. In exercise 6-2, they gave us an annual rate, a period that's been invested, and interest compounded. So we're going to determine the future value of $10,000 under each of the different assumptions that they gave us. So let me just go ahead and type all that in first. Okay, so there's 3 different scenarios. This is 10%. Well, let me just put the percent sign in here first before it goes all whack on me again. Okay, so 10%, 12%, and 24%. Okay. The period invested is 10 years for the first one, 5 years for the second, and 30 months for the third. And then for the interest compounded, this one is going to be semi-annually. This is going to be quarterly. And this is going to be monthly. All right. Okay, once again, we're going to be using table 1, which is future value of a single amount on page P-1. And for the first one, we're looking for, so a problem states so that we know that we have that 10,000 from the problem. Okay. All right. So for the first scenario, we're going to invest $10,000. Okay, this $10,000 at 10% for 10 years. Interest is going to be calculated twice a year, semi-annually. Okay. All right. Future value of $10,000. Our number of periods is going to be 20 periods because interest is calculating twice a year for 10 years. So you take twice a year for 10 years, that's 20 times or 20 periods. Interest is going to be 5%, because remember earlier when I showed you the earlier brief exercise where she had 4% interest but was compounded 4 times a year? Same scenario. We've got 10% interest per year, but it's calculated twice a year. So each period is going to be at 5%. So you're basically taking 10% divided by 2 because that's twice a year. If we had quarterly here instead of semi-annually, we would have put 10% divided by 4 instead of 2. I hope that makes sense. Okay, so with that being said, our factor then is going to be, if you look at table 1, for 20 periods at 5%, our factor is going to be 2.65330. Okay, so my formula to get the answer, then I'm going to take 10,000 times 2.65330. And the future value of that $10,000 for 20 periods compounded at that $10,000 at a 10% annual interest for 10 years, calculating twice a year, we will have $26,533 at the end of those 10 years. Okay, that's that one. Number 2. We're looking for the future value of 10,000 again. Okay, that's going to be the same amount, different scenario. Our number of periods is 20. Okay, and our interest is going to be 3%. All right. Why is it 20 periods? Because we've got 5 years calculating at 4 times a year. So you take 4 times 5, that equals 20 different periods that we're going to be calculating interest. Okay, 20 different times that this amount is going to be calculating. And because we've got 12% per year, and in each year we are calculating interest 4 times a year, take that 12 divided by 4, we get 3%. Okay. So if you take that into consideration, look at your factor. Our factor is going to be 20 periods at 3%. The factor for number 2 is going to be then 1.80611. Okay. My formula is going to be $10,000 times 1.80611. That comes out to be $18,061.10 in 5 years, compounded at 12% quarterly. Okay. Right, number 3 scenario. Once again, we're looking at the future value of $10,000. Number of periods would equal 30. And our interest is 2%. All right. Once again, we've got 30 months. It's compounded monthly, so it would be a straight 30 periods, or every month it's going to calculate interest for 30 months. So that 30 months here, which means we've got 30 periods. And in each, it's 2% because we got 4% annual interest rate, calculating at monthly, and we've got 12 months in a year, so that's going to be 2% instead of 24%. Okay, so our factor then, we are taking into consideration 30 periods because we've got 30 months compounded monthly, so there'd be 30 times that we're calculating interest at 2% because it's a 24% annual, but there's 12 months in a year, so we're going to take that 24 divided by 12 equals 2. Okay, So our factor then is going to be 1.81136. My formula is going to be 10,000 times that 1.81136. That is going to take me to $18,113.60 at the end of those 30 months at 24%, calculating interest monthly. Okay, so that is my amount. All right, so that is 6-2, and that is what they were doing in 6-2, and that's what they wanted. Hopefully, the future value, calculating future values for a single amount looks a lot more clear to you now. The next video, I will show you present value, and hopefully you see the difference once you see the two videos. But that is it for this one. So if you have any questions, comments, concerns, please shoot me an email, call me. I will be happy to answer them.